If you like my content, please like, share and subscribe.
Hello guys, and welcome back to my new video. In my last video I have talked about object oriented programming in part 1 and part 2 basis. Please go check out if you did not already. Today we will be learning about Numpy. So Numpy is a very important Python library that we are going to use extensively in machine learning, data science and artificial intelligence. So again, what is library? Library is basically a set of code that has been written by Python developers. Whoever is contributing to Python community, they have written that Numpy library and they have put it in the standard Numpy module. So you can use that Numpy module to build your own code, and it's extremely fast and extremely performance efficient. You can definitely use Numpy for any kind of mathematical operations, any kind of numerical operations. So Numpy is an open source Python library that used in almost every field of science and engineering. It is a universal standard for working with numerical data in Python, and it's at the core of the scientific Python and PyData ecosystems. This Numpy library is used extensively in various Python libraries that are eventually used for machine learning and artificial intelligence. Those libraries are pandas, scipy. Scipy is basically scientific Python. Then matplotlib is basically for data visualization. scikit-learn for machine learning algorithms. scikit-image for image classification, and most other data science and scientific Python packages. So I'll be starting with Numpy basics, and I will show you how you can use Numpy for Python in our Jupyter notebook. Very good. So let's start. So the very first step that we're going to see is how to install Numpy, because it will not be installed in Python. So you have to explicitly install Numpy to use it. So to install it, we have to type pip install Numpy. Just to remind you, pip is basically a Python manager which instructs console to install Numpy. So you can write this in your command prompt, in your Jupyter notebook, anywhere you can write. It will install globally in your system. Okay, so you can do this command to install it. Now, how to import Numpy in your Jupyter notebook? So they are not be preloaded in your Jupyter notebook. You have to explicitly import it to use it. So import Numpy as np. This np is basically an alias. Okay, so this is a standard thing that every Python programmer is using. So basically what happens in the background is you are importing this Numpy class to your own Jupyter notebook. So if I go here and say import Numpy as np, then all the methods inside this Numpy will be, so basically this Numpy class will be created and it will refer that class as np. So then you can start using np to access various methods or attributes that Numpy provides. So basically Numpy is mainly used for creating arrays. Okay, so what is an array? So an array is a central data structure of the Numpy library. So an array is a grid of values and it contains information about the raw data, how to locate an element, how to interpret an element, everything this array can do. So let's look at the way of how to create an array, how to create basic arrays. There are almost 4 to 5 methods that you can use to create your arrays. So first is np.array, you can use directly to create. Okay, second is np.arange, you can use also to create an array. Third is np.zeros, that you can use also to create an array. Fourth is np.ones, that you can use to create an array. Fifth is np.empty that you also can use to create an array. And one more is np.linspace. Okay, so we'll see all of them individually. So first of all, np.array. So it's very similar to list. So you can create an np.array using np.array. So why np? Because we have imported numpy as np. Okay, so this is the alias of numpy now, so we can use that. So it holds all the objects and attributes of numpy class. So np.array, then you can pass like this inside 1 2 3 4 5. So like that you can pass. Now if you want to see the a elements of a, you can use just enter to see that. So it's basically an array. So if you now want to see the type as well, you will see that it's an numpy.nd array. So n can be 1 2 until n. Okay, so this is an nd array. Very good. Now what is np.arange? So np.arange is basically, it is not arrange, it's a range. Okay, so it's a range basically. So if you want to pass b equals to np.arange and you pass 6, then can you guess what will happen? Correct. So it will create basically an array of elements, number of elements as 6. So again it will start from 0 and it will end at just before the number you have specified here. So it's basically that. So now one very important thing is the methods are very, so there are like numerous methods that you can have inside numpy, right? So every time if you are not familiar with that method, so you can just use np.arange, you can just type, and so if you do shift tab you will see the docstring, the entire description of this arange method basically. So if you just see that it says there are like multiple parameters that you can pass. So start, stop and step is basically, so if you are going to do like this and step is 2, then you can see that it starts from 1 and then it will, step size is 2 1 3 5 7 9 until 10 basically. It will do that. So it's very important to see shift tab and find out what this array is accepting, what it is returning. So if you just expand it, you will see that it returns array nd array, basically array of evenly spaced values. Okay, great. So now if you are seeing this np.zeros, so what it will say? So it's very easy to understand from the name only. If you do that and just say that we need 3 elements. Okay, so what will be the c then? Yes, it's an array of 3 elements, all will be 0 0 0 0. Now you see that 0 dot. Why 0 dot? Because zeros, the elements are by default float. Okay, so here you can pass the data type as int, so then it will be 0 0 0, there will be no dot. See, 0 0 0. So again if you go to this, inside this method and do shift tab, you will find out that this is a shape. Okay, so you can first provide the shape and then d type equals to float, this is by default, and if you pass int then it will take int basically. So you can use this. You can also pass a 2D shape here, like if I do like this and say 3 by 3. So just remember that when you are passing 2D, you have to pass this in a tuple. So I hope you remember tuple. What is tuple? If not, I have an entire video about tuple and list and all, so you can go check out in my Python's playlist. So here you can pass this 3 by 3 2D shape and then all will be int. If you say, then it will be a 2D array with shape 3 by 3 and then all the elements in this C will be integer. Awesome. So now if you if you just want to see the type of this C, it will still say numpy.ndArray. As I told you, this n can be 1, 2, 3, anything. You can also pass 3, 3, 3, and it will be a 3D array. Type C will still be same. Awesome. Now you can do np.ones. It's very similar to np.zeros. So just you can say np.ones, and if you want to say a equals to np.ones and say 1 or maybe 2, and if you want to see a, it will be again 1, 1. Okay, so you can just pass its shape similar to this np.ones, and you can say int, and it will again be 2D array, all element to be 1. Perfect. So why we are using this methods to create a basic array? Because like you need sometimes to create a huge arrays, and creating array by this means will improve your overall programming performance hugely, because numpy is very quick in executing all the commands that you are writing. So always try to use numpy array instead of list if your program is computational heavy. Okay, awesome. Now np.empty. So np.empty is basically again a similar concept, but here the thing is like when you are going to execute it, it will 1 1 now, but the initialization of this empty will be random. Okay, so the first time you are going to run it, it will randomly pour some value. So like if you now going to see 3, let's say here, if I pass here and say 3, and it will be 0 0 0. So the very first time that you are running this command, it will just initialize a array of 3 elements with some random values. So again, if you are going to check the docstring, you will see that return a new array of given shape and type without initializing entries. Okay, so it's basically random. So yeah, I think so. Here if you see that np.empty, they have passed 2 2, and it randomly passes these 4 values basically. So this is np.empty again. Okay, so again the data type is float by default, and you can use, so this is order. This order is basically C. So now we have C means C type array, or you have order as F as well, which is Fortran style array. So this is not very important, but you can still go and check. Now linspace, this is very important. So this linspace is basically linearly spaced array, it will return. Okay, so you are saying that I am going to create an array from 1 to 10. Okay, start and stop, it's fine, but I am going to use this variable, the third parameter, to mention that how many elements you want in your array. Okay, so if you say 5, it will create an array of 5 elements which are between 1 to 10. So see, and which is linearly spaced. So the difference from 1 to 3.25 is same as 3.25 to 5.5. The difference between first and second element will be the same as of second to third, third to fourth, fourth to fifth. It's a linearly spaced, so it's lean space, and it's going to return you an array starting with n, ending with the 10, that is parameter 2, and the element will be, number of element will be 5. Okay, so this is to create basic arrays. So these are the 6 methods that you can use to create your basic array, whatever be the dimension or shape. Okay, it can be 1D, 2D, 3D, ND. Okay, so but you can use that to create an array basically. Don't worry, I'll give you this notebook. I'll attach this notebook in the description of this YouTube video. So I'll just mark it as how to create a basic array. Okay, now we're going to perform some operations on these arrays that we have created. So adding, maybe sorting, or maybe let's say adding, sorting, and removing as well. Okay, so you can definitely perform these operations on this array. So let me show you how you can do that. Right now, so you can definitely use np.sort. So again, you can go, just do tab, np.tab. It will show you what are methods that you are going to have in your numpy class. So you have this sort. Okay, so basically you can create an array like np.array, and you say 2 4 1 6 8, and you say np.sort a. So np.sort a will return an array which is sorted, right? That's it. Now, so you can do so many other things, like if you are creating an array 1, let's say, and you have this 1 2 3 in the array, and you are creating array 2, same np.array, and say 4 5 6. Okay, okay, so this array 1 plus array 2 will just add this elements, corresponding index elements, and create a new array. Okay, you see 579, that is 579. Now you can do array 1 into array 2 as well. So it will say 4 10 and 18, which is 4 10 and 18. So corresponding index gets multiplied, that's it. So these are the things that you can definitely perform on arrays. So these are basically you cannot perform in list, and it's very efficient in numpy. So every time if you are in a dilemma what to use, you should use numpy array. Okay, but one quick difference that I'll tell you is that it's preferable, it's always preferable to use numpy array with homogeneous elements. Okay, you should not mix in a numpy array integer and a categorical value string. Okay, that will impact the numpy performance heavily. Okay, so that's have a very bad impact on numpy array. So try to use, every time try to use numpy array for a homogeneous elements. Okay, awesome. Now, so you can have also, you can concatenate two arrays to make a like one long array. So suppose you have this array 1 and array 2, so you can again use np.concatenate. Okay, and just pass array 1 and array 2. So see, so this is an error. Why? Because I have passed this array 1 and array 2. So you have to pass always it in a tuple, as I told you. Okay, so always pass this in a tuple. So just say this and it will be awesome. So it has been added like at the end of the array 1. So array 2 has been added at the end of the array 1. Basically it concatenates. Okay, so you can use this. So also you can remove, you can use the remove, and the same indexing applies on this numpy array as well, whatever you have already learned in list. Okay, so the list slicing, list indexing, the same thing is applicable in numpy array as well. So you can just say, let's say you have a D array and you have something like, so you have, I'll just say z equals to this. Okay, now, so now you can just do z just 4. So you'll say 5 and 6. So if I just quickly show you what is z, so now 4, it will start from 4 and go at the very end of the array, right? So what is 4? So this is the fourth element, and then 5 and 6, so it will print 5 and 6. So the indexing and slicing, as I told you, it's work as simple as what you have been already seen in list. Okay, perfect. So this is adding, sorting and removing. Now a very important step is to know what's the dimension of an array, okay, or what's the shape of an array, or what's the size of an array. Okay, so these three are very important when you are trying to use some code, or you are trying to extend some already written code and try to see what are the already declared variables and the shapes, dimensions, or the size of that array. So for that you can use three attributes. I'll show you that. So let's say dimensions, shapes and sizes of how to find, how to know basically. Okay, so I'll just change it to markdown for the better heading. Okay, so now you have this z. So if you want to know the dimension of this z, you can do z dot ndim. Okay, and remember it's an attribute, it's not a method, so you cannot pass this. So you have to just say z dot ndim and it will return 1, obviously because it's a 1D array. Now if you want to create another array which is maybe a 2D array, let's say something like that, 1 2 3. Okay, and now if you want to see the ndim, it will be 2. Awesome. Okay, now if you want to create a 3D array, let's say like that, 3 4 5. So it's basically a 2D array also. So if you just want to see the z and dim, it will say 2 as well. But if you want to create a 3D array, now if you want to see z and dim, it will be 3. Now if you want to see the shape of this dimension, shape of this z array, so you can just say z dot shape. So it's 1 2 3. Okay, so this is the shape of the array, row versus column versus width. If you want to see the shape of this array, so you can just say 2 by 3, so row by column, 2 row 3 columns basically. Okay, now if you want to see the size of this array, so the size will be the multiplication of row and column, so it should be 6. Okay, the size is 6. So if you just want to see all of them together, so you have to do print, because only the last operation will be printed in a cell. If you are not explicitly provide this print statement, only the last element gets printed. So now you will see that ndim is 2, shape is 2 by 3, so its shape is returning a tuple with the dimension as row by column, and the size is basically row into column, the total number of elements irrespective of their dimensions. Okay, so these are basically dimension, shapes and sizes. Now a very important stuff is reshape. Suppose you have a array again called z, which is 1 2 3 4 5 6. Okay, so now this is the 1D array, right, and which has 6 elements, but you want to create a 2D element out of it. Okay, so what you can do, you can just say reshape, and you want to create a 3 row 2 column array from this. Okay, so remember you can only create either 2 row 3 column, or 3 row 2 column, or 1 row 6 column, or 6 column 1 row. So the multiple has to be equal to the number of elements. It cannot be, you cannot create a 2 by 2 elements, 2 by 2 array, okay, from here. So it will not be possible. So you can just say 3 by 2. It will be a 3 row and then 2 columns basically. So it will reshape this z with, it will not reshape the z itself, it will return a 3 by 2 array basically. It will not change this z. Okay, so if you want to print z, it should be same. Okay, since it's returning, you are going to see this value in the output. Okay, so this is basically dimension, shapes, size and reshapes. Okay, and I can say and reshapes. Cool. Now, so you can explicitly convert a 1D array with either a row vector or a column vector using np.newAccess. Okay, so this is np.newAccess. If you see, this is the method. So suppose you have a array again, let's say again 1 2 3 4 5 6. Okay, like that. Now if you want to create a row vector out of it, how you can do that? So if you see the shape right now, it's only 6. Okay, it's 1D array, it's not a 2D array right now. So you can convert this 1D array to 2D array using this np.newAccess. So now if you are going to create a row vector from this y, you can just insert an axis along the first dimension, let's say y, and then you can say np.newAccess. Okay, for all the column, it will create a row vector out of it. So if you want to see, it says 2D array, right? So now if you want to see the shape, it is 1 by 6. But if you want to create a column vector out of it, it's just the opposite of that. So you can just say that column vector. Okay, let's say column vector equals to y, then for all the row np.newAccess. That's it, nothing else. So you can just insert an axis along the second dimension. Okay, so now if you want to see the shape of this column vector, you can just do shape and you will see that it's 6 by 1. Very cool, right? Very cool. Yeah, one more method to achieve the same column and row vector, which is expand dims, which is expand of dimensions. Okay, so let's say you have this array with you. Okay, so if you want to expand the dimensions of y, so what you can do is y, so it says np.expand dims. Okay, so first you have to pass the array and along with the axis, in which axis you want to expand. So if x is equals to 1, that is you want to expand in column. Okay, so let's just say this is the column vector basically. So if you see the, let's say it's a1. Okay, so you can just say a1 dot shape. So it's a column vector. Okay, now the same thing you can do and create a row vector as well. Let's say a2, it should be 0. So axis should be 0, everything else is same, axis should be 0. So in this way also you can expand the dimensions of the existing array. So a2 dot shape, if you want to see, you will see that 1 by 6, which is a row vector. So this is a column vector and this is a row vector. So you can use expand underscore dims as well to reshape. So there are 3 methods basically: reshape, and then the newAccess, and the expand dims. So I've changed the heading to this, and you can use this 3 technique: reshape and the newAccess and then expand dot dims to use, and 1D array as a 2D array. Now indexing and slicing. So as I told you already, you can perform all the indexing and slicing as you have performed already in lists. So the same technique you can use here, but I'll show you couple of stuff as well which you can do more in here. So basically say indexing, again I'll change it to a markdown and say let's say you have again an array which is np.array, and you have 1 4 7 8 9 10, something like that. Okay, so you have created this y. Now if you are performing again y colon 2, so it will be 1 and 4, basically from the very first until the second index, which is 1 and 4, not until, it's just before the second element it will stop. So 1 and 4, if you do 1 y 2 colon, then it will basically starts from this the second index, and it will go at the till the end, so 7 8 9 10. So now if you want to do this -1 stuff, then you can also do that. So let's say -1, you will get the last element basically. If you want to do -2 and then all, you will get from -2 until the end of the elements. So these are the basic in slicing that you can perform on index on array. Now suppose you have an array, 2D array, let's say np.array, and say it's 1 2 3 4. Okay, then another row called 5 6 7 8. Okay, then say another row called 9 10 11 12. So basically this should be 2D array, right? Awesome. So now if you want to see the shape, it's a 3 by 4 array, 3 row 4 columns array. Okay, now if you want to just see the elements of this array which are less than 5, so just you can do a and then say a less than 5. It will only return array 1 2 3 4. How cool is it? So it will skip all these elements which are more than 5. If you want to just print a more than 5, it will all print 6 7 8 9 10 11 12. Okay, so this, so in a 1D array basically. Now if you want to see the elements that are only divisible by 2, so for that you can do a modulo 2 equals to 0. You will see that all the multiples of 2 are populated in this array. Okay, so in a 1D format definitely, but it is like that. So there are these kind of stuffs that you can always perform in this array. So slicing and indexing, and also filtering, basically you can do that. You can also use AND operations as well. So you can just say a which is greater than 2, let's say, and let's say a less than 9. So basically you have to pass this in a top bracket basically, just to make it clear to the array. Okay, otherwise it will not be able to understand that which operands we need to take to do this AND operation and all. So you have to specify explicitly that these are the 2 operations that you have to perform, and then you can do an AND. Okay, so you can see that it will only print the elements that are more than 2 but less than 9. So instead of AND you can just say this pipe, and it will return, so it's an OR, so all of them will come because all of them are like having the same, so either of them is always there for each of the element, that is why all will be there. Okay, cool. So this is slicing and indexing for you guys. Now how you can create an array from the existing array. Okay, so how to create array from existing arrays basically, so like that. So again I'll change it to markdown, and let's say you have again an y array which is np.array, and then you have 1 2 3 4 5 6. Okay, Now you can just create an array using this slicing technique again. 2:4. It will return an array of, this is we saw already. Okay. Now suppose you have a 2D array, let's say y1 as np.array. Okay, let's say like that, a comma b, and then let's say you have another row which is c comma d. Okay, so you have to just do this, sorry, like that. So it's a string, so you have to pass like this. Okay, so you have this. Now you have y2 as well, which is np.array, and then you have let's say, so this will be basically 2D array. So I'll just pass the first dimension. Okay, and this will be, let's say, ef. Okay, and then you have another row called gh. So I'll put it in the string. So now we have this y1 and y2. So you can use this h stack and v stack. Okay, so this h stack, if you see, and you have v stack as well. So horizontally you can stack those y1 and y2, and also vertically you can stack, so which is v stack. So let's say v stack, so this. Okay, so these are the two methods that you can use. So let's say this. So what is v stack? V stack is basically np dot, so h stack. So h stack is, so you can just say y1 comma y2. Okay, again I have to pass it in a tuple. Very important, guys. Okay, so you see that horizontally it got stacked. So AC, BD, and then we have EG and FH. These got stacked horizontally. So now the same thing you can perform on V stack as well. So let's say V stack, you do using y1 comma y2. You'll see that it has been stacked vertically. Okay, so these are the very important concepts. You have to, multiple times you have to use this in your machine learning algorithm or in your further data visualization and all. Okay, every time you have to use this. So Numpy is a very important library, so please go through it multiple times, use it. Okay, and do some operations, do some problems on it. Okay, to get more familiar with this Numpy library. It's very important, guys. If you are going to be a data scientist in future, if you are going to be an applied scientist or a machine learning engineer or a machine learning operational engineer, okay, or data analyst, for these kind of roles, Numpy is a very important library. Please keep this in mind. So in our next video we will be learning more about Numpy. So till then, just practice. Let me know in the comments if you are having any doubts, any problems. I'll try to reply to you. Okay guys, thank you and goodbye and happy learning.
If you like my content, please like, share and subscribe.